Hey guys, it's Trey back again with another video. And in today's video, I want to show you guys how you can generate a PNG file from scratch. So basically, we're going to write some code that will literally create a PNG file. But in order to do this, we need to understand what a PNG file is and how the file is structured. So I'm going to go over that today, and in the next video, we'll actually write up some code. Basically, what a PNG file is I'm just going to read this definition. It says a PNG file is a type of raster image that is commonly used on the internet. So basically, you can think of pretty much any file. You know, there's JPEG and then you got PNG. These are like the two biggest. If you don't know what PNG is, it's basically just a file that stores image data. All right, and it stores the image data in in a way that it can be expressed as a matrix. All right, so we're going to basically create a matrix of pixels and we're going to store them in a file, and we will be able to use any picture application that you have on your computer to read that file and display the picture. All right. So in order to do this, obviously we need to understand the actual structure of a PNG. So I pulled up the specs for a PNG file, and basically all a PNG file is just it consists of a signature and a list of chunks. All right, and we're going to go over what all that means right now. So the signature is always these 8 bytes right here. Okay, so I'm going to pull this up over here so you can actually see kind of what's going on. I'm going to put all these links in the description so that you can find this stuff if you want to do some extra research, because I'm definitely not going to be going over every aspect of this. But basically, a PNG signature is just a way for decoders to identify this file as a PNG. All right, so remember I showed you those 8 bytes. Here they are right here, and here's what they mean. All right, so basically that's pretty much it. We don't need to really do much, but just make sure we add this signature at the beginning of the file. All right, so that is number one. I'm not going to really go over this. There's a lot that you can read. Signature does a few neat things other than just, of course, signifying that this is a PNG file. I advise you to go ahead and read this if you want some more understanding. But after the signature, we just have a list of chunks, okay? So what a chunk is basically each chunk has different information in it, all right? And we're going to be using only 3 different chunks, and because we're going to be writing the most simple PNG file that you can write, okay? Um, but let's explain how the format of the chunk is, okay? So a chunk is basically 4 different parts. We have the length, the chunk type, the chunk data, and a CRC code, all right? So the length is a 4-byte unsigned integer, as we see here, and it basically tells the length of the data field, not the entire chunk, just this data field, all right? And that's what that is, a 4-byte unsigned integer, okay? And then we have the chunk type, and this basically tells what type of chunk this is, pretty much. So there's a lot of nuance in this chunk type. They're basically just ASCII characters, so any lowercase or uppercase ASCII character is a valid byte in this chunk type. So since it's 4 bytes, we'll have 4 characters, all right? And whether the characters uppercase or lowercase actually mean something, I'm not going to go through all of that because we kind of don't need to know that for what we're doing today. But like I said, I'll have this in the description, and you can go through and read what all of that actually means. But just know it's a 4-byte ASCII code that it will be used. All right. So that's the chunk type. And then chunk data. This is the actual data that's in the chunk. Okay. So in the case of our actual file, like our actual image, we'll have a chunk for the pixel data, and this chunk will literally hold all the compressed pixel data. All right, so this chunk data field can be anything from 0 up to the maximum. Okay, so I actually don't know what the current defined maximum is, but I'm sure it's somewhere in this file. You guys will be able to research it. You guys are resourceful. And I will post these in the description so you'll be able to find it. For the purposes of the video today, we do not need to know that because our file is going to be kind of small. We're only going to do a 128 by 128 image, okay? So that would definitely fit in here. All right, and then the last thing is the CRC. So basically, CRC is basically a check to make sure that the data is not corrupted here. So we will generate a CRC based off of this chunk data and the chunk type. Okay, so basically we're going to run a CRC algorithm and get the chunk type and chunk data in there and get a CRC out. All right, and it's going to be 4 bytes long, and we're going to put that at the end of the chunk. Okay, and as far as compressing this chunk data, we're going to use a package that will do this for us because we're not going to be writing a compression algorithm. We're just going to use one that's already created, and we're going to be using the package called Zlib. All right, so this is just something that comes with Nodejs. It's like a base package, and it'll be Zlib, and we're going to be using that to compress our image data. And then as far as CRC goes, we'll be using something called CRC32. It has the algorithms for us to do the CRC code. So we're not actually writing any algorithms here. We'll just use the ones that are already there. All right, and that's pretty much it for the chunks. So each chunk is going to be like this. So we'll have a chunk for like a header chunk, and then we'll have a chunk for our image data, and then we'll have a chunk that signifies the end of the file, okay? So we're only going to need 3 different chunks. So as you can see here, we're going to be writing the simplest PNG that we can, and as you can see down here, we have the 8-byte signature that we're going to need. Then we're going to have this IHDR chunk. Then we're going to have this IDT chunk. We're going to have this IEND chunk. All right. So this is basically the header for the file. This is the data, which is going to be our compressed image data. And this is just a chunk that signifies the end. It is actually not going to have any data in it. So the length will be 0 on this chunk, but it just signifies the end. All right. So let's go through and discuss these chunks in more detail. We're going to start off with HDR. All right. All right, so we have the IHDR chunk here, and basically this is the layout of the data in the chunk, okay? So we're gonna have a width, which is 4 bytes. We're gonna have a height, which is 4 bytes. So this is basically the dimensions of the PNG image. And then we're gonna have the bit depth here. Okay, so this is basically giving the number of bits per sample, all right? And then we'll have the color type. This is basically going to tell us how our color data is stored, basically. So we're going to use this number 6 here, and this is basically going to allow us to use, here we go, if I scroll down right here, 6, we're going to be able to have RGB and an alpha. So basically we'll have a RGB color, and then we'll also have a transparency associated with that pixel, okay? So that's the color type. Then the compression method, there is only one compression method that we're going to be using, and that is the deflate / inflate compression method, and that's where we'll be using Zlib to do, so we don't have to really worry about that. We're just going to set that to 0, and when we actually compress our pixels, we'll use the Zlib to do that. Filter method, we are going to use 0 for this as well. Not really going to explain that because we're not really going to be doing much with that. And then also interlace method will also be 0. We're not going to be doing anything with that as well. All right. So that is the IHDR header. All right. So that will be our first chunk. We're going to define all of these bytes, and then we will store that in the file. Save that to the file. Okay. The next chunk that we have to deal with is the IDT chunk. And this is where we actually put our image data, all right? So basically what we're going to have is, let me go back here so I can show you. All right, we're going to have the length. We will figure out the length once we have our data. And then we're going to, the chunk type will be IDAT, of course. And then the chunk data will be the compressed pixel data. So we're going to compress the pixel data using Zlib, as I said a couple of times in this video. And then we will generate a CRC based off of these two. All right, all that's going to be done in code, and that will handle our IDAT. And then the last one is end, and this is basically just an empty chunk, and it just signifies the end. So basically, we'll have a length of 0. The chunk type will be end, and the data will just be blank. And then we'll actually generate a CRC based off of the end chunk type code. All right, and that's pretty much it. Once we do that, we can go ahead and run the program and see if it generates a PNG. As far as the actual pixel data goes, I think we'll just create like a square or something on the screen. So we'll write some code that basically says, hey, if you're in the square bounds, color it a certain color. And if you're outside of the square bounds, then just, we'll probably just paint it white or something, or transparent or something like that. All right, so we should see a square in the middle of the screen. All right. That's pretty much it for this one. This was just an introductory. In the next video, we're actually going to jump into some code and write all of this out. Thanks for watching. Like, subscribe to the channel and all that jazz, and I will see you guys in the next video.